Hello, everyone, and welcome to another episode of the Net.lol. I'm Kyle Mestry. I'm joined this week by my co-hosts Brent Salisbury and Tom Nadeau. We're happy that you're able to join us to get your sampling of networking this week. This week we're happy to be joined by Vinny Parla, a co-worker of mine, a good friend of mine. We've done a lot of fun collaborating over the last few years. So, Vinny, welcome to the show. Would you mind telling everyone a little bit about yourself?
Sure. Thank you for inviting me, guys. I really appreciate it. So I've been at Cisco for a long time. I've worked the majority of that time in the security business group, done a variety of different things. I'm one of the original inventors of DTLS VPN. So if you've used any Connect and ASA, your packets are traversing a protocol that I was one of the co-implementers of. And then I've done a lot of different things in security with a lot of focus most recently in cloud and also DNS. So I was one of the driving forces behind us enabling DDR, which is a new DNS protocol for discovery. And Umbrella at Cisco is the first to actually publicly announce implementation of that. And we're hoping that some vendors are going to announce here shortly as well that they'll be supporting this protocol. So what I've been doing for the last year or so.
Yeah, and that's kind of where our paths have crossed recently as well, as on the cloud security side,
Yes.
for sure. So I thought one of the things that we wanted to talk about was, and I think we'll get into it, it would be interesting to talk about some of this protocol complexity. You mentioned DDR, some of these other things as well. But before we kind of jump into that, because one of the things we want to talk about in terms of protocol complexity is QUIC. So do you want to give maybe some of our listeners a quick overview? A quick overview. I know that was pretty good, right? Everyone saw what I did there, I hope. Yeah. Vinny, you want to give us an overview of QUIC?
Yeah, sure. Let me share a couple very brief slides just to visually show the complexity of the protocol, and we can then talk to it. So
yeah, and just for our listeners who aren't watching the YouTube video, if you're on Apple Podcasts or Google Podcasts, we will have the slides up on our website, thenet.lol. If you want to go to the episode that you're listening to there, you'll be able to follow along with the slides.
So I hope you can see my PowerPoint deck on the screen.
Yeah, we can see it.
Yeah.
So walk us through what we're looking at here, because this does look complex.
So if you think about the QUIC protocol, one of the goals of the QUIC protocol is to, and it'll be leveraged as part of HTTP 3, which is going to be the next generation of HTTP. It's essentially moving you from a TCP-based web protocol to a UDP-based web protocol, which has all sorts of advantages, right? You have, you don't have the head-of-line blocking type of problems that you would have with TCP and TLS, so you can process packets out of order. That's a great benefit of it. There's all sorts of optimizations that have been put into the protocol, so you can do zero round-trip time protocol negotiations. So basically what that means is you can, as you're setting up the connection, you can actually start sending some of the data packets along with the initial connection setup. So if you're familiar with traditional like TLS exchange, you do a whole server and client negotiation, and then after doing that negotiation, you start sending the data packets. So in QUIC, one of the optimizations there is you can do a zero round trip time solution where you can actually start sending your data packets right away. So there's all sorts of great optimizations there. But with this comes
And for
complexity,
the
right?
folks listening, Vinny, so in terms of like what applications they'd be using today, that might benefit from this, you're showing like is screen cap from YouTube, a PCAP from YouTube, right? So,
Yeah, yeah.
I mean, do you have other examples maybe that where people will see this as an advantage?
Well, where this will be very common is in browsers. So all of your web traffic will go over a QUIC protocol. That's what HTTP3 defines as the protocol for doing this. So any web-bound traffic is likely to leverage this protocol, and the advantages are, as a user, you're going to see hopefully better performance in terms of just the initial startup of the connections. And if you've ever looked at a normal web browser connection, one web page might end up being really 100 connections in the background to all sorts of resources, embedded content from third parties,
And
icons
each
and
one of
images.
those has a startup, et cetera phase, right? For every
Right,
single one of those, right?
right. So if you have 100 of those connections, each one has that startup phase. And so, QUIC is helping to improve that by reducing the round trip times before you start sending data. So that's sort of the goals of it. Um, but if you look at it, in the right side of the screen here is just a list of all the different packet types in QUIC. And as you can see, if you compare this with just like a normal like TCP, HTTP type of protocol, there's only a handful of sort of packet types in normal HTTP traffic. In QUIC, you've got, over 20 different packet types that are possible, and that means any solution you're going to build has to be able to parse this protocol, deal with those different packet types, and each of those packet types have their own format. So, there's a great deal of complexity that's introduced there. Also, part of the goals of QUIC is to move all of the retransmission logic up into this QUIC application layer. So normally the retransmissions you'd see done at the transport layer in TCP are now moved inside the QUIC protocol. So now if you think about it, QUIC is really becoming the new TCP. So you've moved up the stack and built a lot of the reliability that was built lower in the stack into the application protocol. And of course that adds complexity, right? Because now you've got to have logic to handle retransmissions and, out of window in terms of if you have a real-time protocol that you have some windowing, you have to deal with that in the protocol stack. So this really has added a lot of complexity, and it makes it really hard if you're building hardware-based solutions because you've got to, build all of this complexity into the silicon, and that's a hard thing to do. And as it gets revved, one of the things in QUIC is that there's a protocol version, and it could get revved often, and you would have to, have hardware that now has to keep up with that rev, right? It really is focusing it more as a software stack. So, the hardware really becomes less relevant, and it's more about this software layer where everything is moving. And the
Well,
interesting thing
and,
about,
and
sure, go ahead.
I was going to say one of the other interesting things which people should be aware of. I mean, all of this is built on UDP, right, as the transport protocol. But
Right.
like you said, all of this complexity is moved into the application. Whereas before you rely on the operating system, right, to handle all of this in TCP. And anybody can just use TCP and take advantage of that. Now with this, that complexity of retransmissions and everything is all moved into each individual application. So it's a
Right.
the complexity. So yes, the operating system layer less complex because it's UDP, but up the stack much more complex
But
because
but the
now each
interesting thing
application
here
has it.
too is that you're moving the marshaling of all that up, right? So that the like Vinny's example at the beginning, we had 100 sessions starting up. You're doing the whole TCP ramp up thing, and that is clogging the queue. There's only one queue the operating system's processing, right, for that output queue. There might be other applications trying to jump in there too. This pushes it up, and I guess I wonder. I mean, in my mind, that's not necessarily a slam dunk of a better option. I guess it depends, right, on your real-time processing requirements and things like that, right?
Yeah, I think it moves the problem.
It
So I
moves it
don't
right.
think it,
It's not
right,
free lunch situation.
right. And so, I think it just moves the problem to a new place. It doesn't make it simpler or easier. It moves the problem, and I'd argue it actually is making it more complex. And I think to point out to what Kyle was saying is, you have really three major, maybe four major OSs, right? And those stacks have been baked over many years. And those four different implementations have all sort of perfected the protocol layers very well, right? Now you're moving up this into the application layer where you're doing this QUIC protocol. Different vendors are going to use different stacks, right? And it may get highly fragmented where you may, on a single platform, have 7 or 8 applications using different implementations of QUIC. And, the quality of those implementations and the bugs and potential security vulnerabilities on those implementations will multiply by the
Right,
number.
they're amplified exactly on that
But,
platform.
but I think that's the point though, to some extent, right? Because let's look at Google as an example. Google is using QUIC in Chrome, right? Google controls Chrome. They also control, obviously, their own search domain. They control all that search traffic. They have AMP. Increasingly, they're driving publishers' traffic as well.
And the
So to
browser
them, they
that's
don't, I
using
mean,
that too.
this is super beneficial to someone like Google because it's using UDP underneath, which, like you said, Vinny, UDP is baked in everywhere. That's fine. And they don't necessarily care about the interoperability, perhaps, right? Because it's just their browser and their back end, right? So they can go as fast as for them. This is very advantageous because they can iterate as quick as they want because they control both endpoints.
Well, I think the hope here too was that because they put the implementation in WebKit and et cetera, that
That's right.
it would proliferate. But
Yeah.
Yeah, and
your mileage varies, right?
I think that's the goals of vendors like Apple and Microsoft. If you look at the protocols, like if you look at DNS, right, they're big drivers behind DNS over HTTPS, right? So if you think of that, they've moved DNS up the stack, right? And what they're really trying to do, I think, is focus all of the technologies around web protocols, right? So I do think that the OS will come with very good implementations of QUIC as an OS API feature that application developers can leverage, right? So as you said, WebKit, right? So you'll go on an Apple device and you'll program to the WebKit interface versus bringing your own QUIC toolkit. So I think that will help mitigate some of the problems because, Apple will put some good resources behind building a very solid stack. Microsoft will do the same. I think the Linux community will coalesce around some implementation and offer, similar to how OpenSSL became sort of the de facto standard for crypto.
Yeah, yeah.
It's got its own warts, and that's why things, different SSL, like boring SSL was an outcome of the complexities in OpenSSL because it had too much in it. But you could see a boring SSL type equivalent QUIC stack that's on Linux that everyone sort of plugs in and agrees to use. So I think those benefits will come over time. But, these protocols are still really, really complex, and they're going to have bugs in these implementations and security vulnerabilities.
Yeah.
And they're not getting simpler. And you'll see some issues around this. Like if you look at so there's an IETF spec on load balancing. If you look at the problems that have been introduced, QUIC has introduced a problem, the way connection IDs are negotiated, and I'll talk to that real briefly. But it's introduced a problem where load balancer, there's a whole QUIC load balancing proposal to deal with load balancing because something that once was very trivial to do with TLS and TCP streams becomes incredibly complex to do with QUIC.
Yeah,
right?
if you throw out the out of order constraint, now you got to deal with it. Yeah.
Yeah. So one of the features of QUIC is that you can negotiate connection IDs. So the client essentially sends its connection ID to the server, and the server sends its connection ID to the client, and they map up to IP addresses. But one of the features of QUIC is you can roam across interfaces and change IP addresses, so you can do things like multipathing and things like that. But one of the features of QUIC is you have the ability to negotiate new connection IDs within the encrypted channel. So this means none of the network fabric could know that, right? So if you have a load balancer that's based on not doing man in the middle, but just based on doing transport layer load balancing, it doesn't know that you've migrated these connections because that's within the encrypted channel.
Yeah.
So you can have a load balancer that's no longer load balancing to the right node based on just how the user is using that protocol at both ends. So it's little subtle issues like that that can create, a fair amount of problems. And Kyle and I have talked about this a lot.
And
right?
the problem is it spins up a new working group to try to solve this, right? Which adds a new draft in the
more
IETF.
complexity.
More complexity, right? And I think that's where you're headed with this. Correct me if I'm wrong, Vinny, but it's finding these little subtleties and then trying to address them. Just kind of adds layers.
Well, and to throw onto this too, like finding the subtleties, you hit it, right? Troubleshooting this is an adventure, I'm sure, compared to a TCP implementation,
That's right?
Right. So
Because
now
of what
you've got
you just said, Vinny, right? Like, well, we load balance
sure.
randomly this way, or well, I don't know,
Right. So one of our coworkers, Raj, who's been doing a deep investigation on QUIC protocol and how to work in terms of networks, right? So, for us, it's a big concern because we have all sorts of man in the middle boxes for doing security, right? And, doing a man in the middle of an HTTPS stream is fairly trivial, right? You terminate the TLS session. The protocol inside is fairly simplistic. Even if you have an application protocol inside of HTTPS, it's parsable. It's fairly straightforward. Well, now you have to deal with this very complex QUIC protocol in your network appliances. So you're introducing that whole stack in those network appliances. And one of the elements of QUIC is they want to be able to break middle box functionality. So they've actually got this concept of a QUIC version so that if your middle box doesn't talk the QUIC version, it doesn't even know how to parse it or deal with it, right? And that was sort of one of the design goals, was to make middle boxes less relevant, right? It's really an end-to-end thing. You've got an endpoint and you've got a server, and the goal of this protocol is for those two to have a connection together and everything in between to sort of be commoditized. And if you look at the folks driving the latest IETF drafts, they're endpoint vendors and CDN vendors. So it makes perfect sense for them, right? Because, a CDN
makes life better for them.
Right? Because a protocol like QUIC, in addition, has multiplexing capabilities, so you can send multiple streams in a single QUIC session. So a CDN loves that because they become an aggregation point for all of your web traffic, right? And the endpoint vendor loves it because they have end-to-end communications with that CDN, so there's sort of a level of guaranteed of service of what you're getting out of that solution, right?
Yeah, the intermediary is a black box, they hope.
Right, and all of those intermediary nodes, whether it's ISP's network or a corporate an enterprise network, they're just dumb boxes at that point. They can't provide any real value in terms of, accelerating that traffic, giving differentiated service, micro-segmenting. There's like all sorts of things that become harder to do when you have this end-to-end.
Well, one of the things, one example of what you're just describing is like enterprises scan and monitor traffic. It's just what they do, right? And security vulnerabilities, all that. And so you can imagine, like, the load balancing thing we were just talking about, a scenario might be you come in through this firewall on this one, and then you come in over here, and then they need to glue it all back together to say, well, wait a minute, that's actually part of the same stream of traffic, but it's been load balanced somewhere behind us. And
Yeah, that's an
and
excellent
that's
example. In theory, you could have some of your traffic go over an LTE interface and some of
yeah,
your traffic go over a Wi-Fi interface. In theory, that's possible, right? I'm not saying it's going to happen, but you could imagine, if you're on an enterprise Wi-Fi network and you have a multi-capable device, that session might migrate to the LTE interface and the Wi-Fi and enterprise network never even sees the traffic.
right. Because the reason why
So,
we haven't been doing this in the past is one, the ordering constraint. The other is, NAT gets really badly broken when you start doing that if you're not careful, from a NATed network.
yeah,
There are multiple exit points for the same stream. Then re-identifying it and all that stuff gets just complicated, right?
yeah. And so there's a protocol called DOC, which is DNS over QUIC, right? So now you have the potential problem that browsers can aggregate content and DNS requests in the same channel. And if you're doing any type of DNS policies, you can't do that anymore because the traffic's invisible to you.
Yep. Yeah.
And you now have to deal with both DNS and content multiplexed in a stream going to some terminal node somewhere, whether that's a CDN, and all of your fabric in between has zero visibility into that. It just
Yeah, and the
looks like,
interesting knock on to this, I was talking to a big operator about similar thing a couple months ago about this. And the thing, see, I mean, we were talking about this at the beginning, like this is optimized for the ends, not the people in the middle. And so for this operator, they've, the last 5 years, have re-optimized their whole DNS infrastructure and their CDN infrastructure to assume that there's some local, caching, basically, of these things. And what's happened with solutions like this, where it gets basically tunneled out and it's opaque, is they can't do any local redirection to a local cache. And what it ends up doing is it costs them in transit traffic, is what it ends up costing, because it's got to go out.
right.
And it's in that opaque bucket. So charging and for it and all that stuff gets hairy as well. That's the flip
Yeah, the
side, I guess.
caching is another great example. I'm glad you brought that up because that's a big problem for service providers that want to cache content.
Yeah, how do you do it with this?
Exactly. And
How do
when
you
you start
pick
doing,
what the customer is actually looking for?
yeah, yeah.
Well,
So
and
any of those
I think some of
in-network
this,
optimizations are hard to do. Yeah.
and I think some of this goes back to something you mentioned a few minutes ago, Vinny, which is, you know, who's driving a lot of this standards work now, and kind of to what goal, right? I mean, a bunch of us on this call have been involved in standards work right in the past, and you look back 20 years ago, it was the vendors doing all the driving of the standards work, right? And that was it, and the equipment vendors were doing it, and now it seems like it's becoming more the content providers are,
It's the
right?
ends
It's
again.
the ends, right? It's the CDNs, it's your hyperscalers, your device or your the browser people. I mean, Mozilla's been huge in standards for a while, right? And so I think that's having an effect on the results and what's coming out and where the standards orgs are prioritizing things.
Yeah, and the stated goals to break the middle boxes. I mean, those are stated goals. So
Yes,
it
for
really
sure.
is to try to evolve the standards to an end-to-end solution and really just sort of cut the middle boxes out of the equation altogether. And there's good benefits to doing that, and there's downsides, like everything, right?
Yeah, that's kind of what I'm trying to tease out of there are pros and cons to doing this. It's not that it's terrible that you've relaxed the constraint of ordering, but on the other hand, this is what you get. So if
Yeah.
you can deal with that, go for it. I mean, one of
And
the things that
this is
I'm,
why enterprises have trouble, right? I think is like you were saying, Tom. I think some of these enterprises are maybe flat out blocking QUIC on the way out
yes,
the door, right? Because they can't deal with it.
you can't deal with it.
And I
Yeah.
think that's what Vinny was going towards too, because, the investment they have in protecting things involves cracking things open and looking inside, and they can't do that. So they
Absolutely.
just said, we're blocking it.
I mean, and as a network operator, I mean, and like Brent, maybe is the thing for you to jump in on. Can you imagine having to unwind something like this that breaks, when you were doing this?
Yeah, I mean, sometimes it feels like we're adding complexity to add complexity because that's what engineers do well. A couple questions for you, Vinny. So, I know, so UDP, we're kind of, the idea is to just to put it in potato head terms, the idea is to shift from from TCP to UDP. UDP offloading, I think, is in most like V2, V3 clouds at this point. I know that was an
All the
initial
popular next to
concern.
it, all that too.
Yeah, yeah.
Yeah.
So I think that problem's getting solved. Maybe talk to us a little bit for the operator out there. Like, why is getting away from TCP such a priority? And then also, I'm curious if benchmarking has changed between TLS and QUIC. Because last I looked, it was fair, like throughput with 100% pegged CPUs, kind of on par with one another.
I think one of the big drivers is the low round trip time option, 0 or 1 round trip, right? So I think it's that cold start that Tom spoke about earlier with TCP, that when in a browser session you might have 100 independent connections to different web services, and that's 100 TCP cold starts that have to ramp up. You have to do the TLS, the full TLS handshake between the client and the server, right? So client hello, server hello.
I mean, just for people listening that don't understand, what is that, like 6 or 8 exchanges total, if nothing's lost? It's something like
Yeah,
that. So we're talking about upwards of round numbers, 1,000 exchanges that have to happen in your 100,
right.
resource example. It's like 6, 8 packets and exchanges per request, basically, per session.
Right. And so, QUIC with the improvements that they're making in QUIC, the goal is to sort of reduce that cold startup. Whether it's a 1 round trip or a 0 round trip, if you can opportunistically send encrypted data, and if you've negotiated the handshake correctly, you can, the data can be decrypted by the server, right? But I think more typically you'll see 1 round trip time implementations. But still, that's far less than what you would have in a normal TLS session. So now if you
I mean, are there stats on that? Like, have people tried, like in practice, like in a real network, like done the analysis for like, is QUIC really, for each one of those sessions that you're avoiding all the startup, et cetera, and basically the overhead to manage the session, is it actually working out in favor of the QUIC implementation, and that, are we really saving 80% or whatever of the chatter at the beginning, and things still go, or are we losing packets and things like that? It's not really helping anyway, because the QUIC requests are getting lost anyway, so they got to try again, which is what TCP would be doing anyhow.
Yeah, I think UDP reliability on the internet has grown significantly. I don't think you see the kind of lossiness you used to see. And in fact,
It used to be pretty high.
DTLS VPN is based on UDP, right? And we've had something like 200 million clients out there that are doing VPN over DTLS today. And we've had very little negative feedback on performance there. Now, granted, VPN's a little different because the inner protocols deal with reliability already. So you're tunneling TCP over UDP. You lose a packet, the inner TCP will retransmit as needed.
Right.
But in QUIC, they've sort of done that same thing by putting it in the QUIC protocol. So they've got the retransmission logic in the QUIC protocol.
That's what I mean. Like, is that overall, like, result? Is it faster to load the pages, for example? Is it really faster?
I know Google's done some benchmarking. I can't speak to it, but the claims are it is better performance, and I have no reason to believe it's not. Like, I think in certain use cases it would be. If you do something like multiplexing, you also would have the advantage. So if you have a QUIC proxy, in the cloud as a CDN, and you multiplex those 100 independent connections inside of of the QUIC connection, then the optimized connection that the CDN has between the service provider components and themselves going to have very little lossiness on this side.
Yep.
Most of your lossiness is between the end user and that proxy at the CDN cloud. So in the case of multiplexing, you don't have 100 startups, right? You have one, and then you're multiplexing all of your stuff inside that, which is tunneling, right? If you think about it, it's no different.
That's really, you're right. It's just another tunnel, right?
It's just another version of DTLS VPN, right? It's literally the same thing as doing DTLS VPN to a cloud service. That's what you do in that case with multiplexing. So it would be no different. But you definitely would eliminate a lot of those 100 startup times for the cold starts for TCP and TLS.
Yeah, I was just wondering, like, on a link, that's relatively lossy, Wi-Fi or LTE, 5G, whatever. We are getting packet loss anyway. Will the UDP approach have to retransmit anyway? It'll.
Yeah, I don't think it gets away from the retransmission problem. If you lose a packet and you got to retransmit it, you lose a packet and you got to retransmit it, right? That's reality. They've just moved that logic up into the QUIC stack, right?
Yeah, so we're still doing it. That's what I want people to understand, is that we're moving it from here to here. Yeah. It's not disappearing. It's we still got to do those things to get the sessions to come, to get eventually to get the resource to come back that you're asking for.
Yeah, and I'm sure there, some of the folks who worked on the actual RFC, could speak to any improvements they've made in terms of retransmission logic that might be better in QUIC than it is in TCP. I couldn't claim to be that person, right? So,
just interesting to think about it, because it's, I just want people to understand and appreciate that there's a min, max, and average for all of these approaches, and we need to consider, like, what are the advantages and disadvantages using this instead of the other, the previous approach.
Yeah, I would have to say it's probably just that low round trip time optimization. I think that's really the biggest benefit. And it comes at a fairly high complexity cost. So is that trade-off worth it? Is, I guess, right, the question, right? Right, and I think people would argue it is, because once these stacks get well developed, there'll probably be a small number of them out there that people will rely on. So, someone will use Chrome's implementation of QUIC, or it'll be baked into the OS. That's the other variable, right, is the actual implementation, right? Yes. That's why it's hard to compare apples to apples. You got to make sure you use the same implementation for both variants,
Well, and I think the other thing, to what Tom said, in terms of, I don't think people generally will have a choice with this, right? I mean, I think at some point dictates it. Well, that's true, and from that perspective, but even as a consumer, if you download Chrome and you go to surf the web, I think now you can probably, if I remember right, you can still enable or disable it, but I think soon it's going to be, there is no choice. You're just like, it's going to default to QUIC. And if for some reason it can't, then it will fall back to, regular HTTP. But so I think the choice is, there is no choice. And like you said, Tom, inside the enterprise, the choice will be just taken away by whatever they're enforcing, on their firewalls, for example.
Interesting. Wait, I'm looking this up in Chrome as you're talking. See if you.
Yeah, I'd be curious to know.
Configure it. I can't find a config anymore.
I thought you. Yeah. Go ahead, Vinny.
HTTP 3 is using QUIC under the covers, and that has been ratified in the IETF, so it's just going to happen. Yeah. Very different than HTTP 2, which happened, right?
Yep.
And as Kyle pointed out, the browsers will just make this the default behavior. I'm sure WebKit will make it the default behavior. WinINet on Windows will make it the default behavior, or WinHTTP, whatever the.
Yeah. So the only way to actually turn it off is to block it on the way out or something, right?
Right. So you'll either have to go into like, Internet Explorer and turn off HTTP3, explicitly, or in Chrome, or, in Edge browser, whatever it is, Firefox. You'll have to explicitly disable it. It'll just be enabled by default.
Or if the enterprise blocks it, their
right.
their infrastructure is blocking it. Yeah.
Right. And I think that's going to be hard for enterprises because at some point, the web services will only support HTTP3, right? So you can't force a downgrade because the actual content providers will coalesce around this protocol, and you will.
Yeah, they'll stop serving on the old.
And you're going to then have, you're not going to be able to get to Salesforce.com because it only does HTTP3. I mean, that's, that's an inevitability because people don't want to have to manage multiple protocols. Salesforce doesn't want to have HTTP2 and 3 running in their services to serve their customers. They'll just go to the latest protocol.
Right, especially if 10% of their customers are using HTTP2.
That's right.
Because they've been automatically upgraded and have no idea how to downgrade it anyway. Yeah. It's kind of going to happen.
So. And you brought up a great point earlier, Tom, which is the in-network troubleshooting, right? Because is it the protocol that's the issue? Is it the network that's the issue? It's going to be...
Or the implementation.
That's right.
Yeah.
That's right.
Yeah, it'll be hard to troubleshoot these problems.
I mean, that'll be a funny situation if you're sitting there, troubleshooting this and it's broken with Chrome, but you bring up Safari and it works. Wait a minute. This is tricky. For an enterprise too, because this used to be easy where enterprises would say you have to use IE or whatever one thing. I don't know anybody that really does that anymore successfully. So there's like another layer of complexity. There's another layer of combinations here.
Yeah.
With the implementations,
So
Sounds like job security to me.
So we're getting close to the end here, Vinny. So I thought I would leave you with one wrap-up question here you could talk about for a few minutes. So we spent the whole time talking about QUIC, which was actually pretty awesome. So tell us where you think this goes. We talked about, for example, a bit like how does this impact hardware? Do you see this being optimized a bit into silicon in places going down the road? I mean, talk a bit about that for us here for a minute.
Yeah, so the big problem, in at least in the vendors I've spoken to that are doing like smart NICs or doing silicon, and they have this problem today. They're really good at doing bulk crypto and packet processing optimizations. So, if you're doing a protocol that's not really a stream protocol, but you're just processing packets, the raw packets, and you want to do optimizations, the silicon implementations are very good at that. What they're not good at is stream processing. They don't do TLS very well in terms of streams, and they certainly won't do QUIC and a UDP encrypted stream over QUIC well either, because there's a lot of reassembly you have to do to get back to these frames, and these stream frames are where the data is, and that's where all the optimization has to happen. So you'll be able to do some limited optimizations in silicon, but I think we have to rethink our implementations, maybe take advantage of things like P4 pipelining and do some of the implementation that way.
Or BPF.
But I think it's going to be harder for silicon implementers to do like a full QUIC stack in silicon. Yep. Certainly, if there's a vendor out there that can do it and they hear this podcast, reach out to me. I'd love to talk because I think that's a big problem.
Well, that is a thing. I mean, you might get an implementation on a NIC anyway. For example, on a NIC is the hardware form factor anyway. Because like I brought up the BPF thing, and then I remembered like we're running entire operating systems on NICs now. We're running the entire Linux distros on NICs, so you'll get its implementation anyway on the NIC.
Right.
Yeah,
Right, but you're still doing it in software though.
But it's still in software, right? Even though it's, even if
right.
it has FPGAs, et cetera. Yeah.
Right. So I think to get it to a really hardware-based parsing, protocol parsing, and processing ecosystem is going to be hard to do with QUIC. I think there'll be some areas of optimization you can do, but I don't think you'll be able to fully implement QUIC in hardware.
And even when it is in hardware, I mean, back to operationally, you got to deal with that too. It's another layer around that.
Yeah, and if QUIC changes their version, which is one of the design goals of QUIC,
all those change
is to be able to rev versions quickly of the protocol. It's much harder to implement in hardware because it takes years to develop things in hardware as opposed to months in software. So
you don't respin an NPU in 6 months.
It's going to be. Well,
so now you're going to have a lot of obsolete hardware that might do QUIC version 1 protocol parsing and acceleration, but can't deal with version 2 and 3. And so what's the value of it, right? Unless you have a good way of implementing very fast programmable hardware capability.
That's cost effective.
I think you're going to.
FPGAs and PCs is probably not cost effective,
Well,
right?
I think this is actually a good segue into a future podcast where we bring on some folks from like Intel and NVIDIA and such and talk about that. But yeah, this was great. Vinny, thanks for joining us. This was a great discussion on.
Thank you for having me. I really appreciate it.
Thanks for being on our Halloween special.
That's right. That's right. For those listening,
this is for when it gets posted on New Year's.
Well, Halloween, New Year's, it's all the same, right?
So. This is our New Year's edition.
Look, Brent dressed up for us today anyway,
That's right. We're all good.
My tux is at the dry cleaner. Yeah, Vinny, I think I'd love to have you back too on talk about some of the DNS aspects.
Yeah. Sure, I'd love to. I'd love to talk about Kubernetes complexity too.
Oh, that's going to be the next one.
That's another one.
We can all cry together.
All right, guys. Thank you so much.
Well, this was great. So, Vinny, thanks again. Thanks, everybody. And a special shout out to our sponsor, T1 Nexus, for sponsoring all the insanity you just got to listen to. So thanks a lot. And we will see you all and talk to you all on the next episode of thenet.lol.
Thank you.